So we're jumping ahead. We've skipped over quite a few of these chapters, but we might come back to them in the next session. So we've got an overview, then a look at the strategy, and then some details on the specific integrations with the different products that we have. So OSLC is now governed by OASIS, the Web Standards Consortium. They took ownership of it a few years ago, before it was kind of standalone. It's a set of standards that makes it easy to integrate lifecycle tools together and to share data between them. So the intention is to really help software vendors manage and define integrations more easily and provide all of the capabilities needed for the users of those tools. And that means really enable end-to-end processes that cover the entire product lifecycle. And you see on the OSLC website, it says achieving the digital thread. And the initial focus was really on ALM and PLM integration, but it's grown beyond that really to any tool that is involved in the end-to-end design process. The key principles are that it focuses on the interaction between the systems, the links between, not the behavior of the tools themselves. So it tries to normalize the behavior of different design tools so that the information can be shared in a common way. The integrations are loosely coupled. So the data lives in its own system. It's not copied anywhere else or synchronized to another system. Instead, we just manage links. And this is a much more robust and stable model for integrations. Link to the data where it resides rather than take a copy of it somewhere else, because it will become out of date. It will become incorrect and stale. If you're linking to the actual data, you know that when you look at it, it's always the right and the latest, or the right version that you want to see. OSLC uses the notion of upstream and downstream systems. So really following the process that you use for design, typically requirements will be upstream, the first thing you do in the process. And then functions will be downstream to that. Then the logical structure, then the physical structure. So in that kind of generic process, items are connected to the upstream system and they're dependent on those upstream data elements. Items in systems are called resources. So when we talk about a requirement or a block or a part, in OSLC terms, it's really a requirement resource. And that's the OSLC normalized resource. They have URIs, so a web address that will explicitly address that item, that resource. So you'll have seen with our systems that when you have a URI, you can get straight to that piece of information, that item, using that URI. OSLC links are defined as a URI reference from one resource to another. So when we create a link, really all we know about the external data is that URI. We really store the minimum of information in the system and just the URI. That enables us to then contact that system, access that information using that URI. And that shows you how we have that loose coupling. And this means that we have two relationships or two roles in this relationship, really. One system is a server or a provider. That is the system that has the information. So it has the requirement or it has the part. And it exposes it or provides it to other systems. And then you have the other role, which is the other end, the consumer or the client. They are connecting to an external system and looking at that information in there. So here's an overview of our solutions. So putting all of this together in the PTC world, we have RVNS for requirements, Modeler for functions and logical structure, Windchill for the physical product structure, and also in Creo, Windchill and RVNS for software structure and software designs, third-party tools for testing or requirements or CAD, and then validation in RVNS at the end as well. And then we have connection to the real product in operation and production and service phases. So these are the different systems of record that are the suite of design tools that our customers will use. And we want to provide user interfaces on top of all of this. They're either native to the system, like Windchill here, or we have apps that are built on top of the APIs to connect. And we have some examples of this as well. Here's a ThingWorx mashup that connects to Modeler and ThingWorx and RVNS as well, I think. Or possibly even AR apps that connect to those systems of record. And this is an example of RVNS showing test verification against an AR model. So this is the high-level strategy, and this has really been evolving over several years, as I said before, and this certainly resonates with customers that this is the kind of challenges they're trying to solve, and PTC are moving towards connecting all of these tools and enabling that digital thread. So Modeler has an OSLC client, and we can connect to these different tools. We can now also connect to Siemens Polarion. It's not listed here, but so when Modeler's the client or the consumer, we can connect to these systems, look at the data inside them, and create OSLC links to those items, to the requirements, to the parts, or to model elements in Modeler. You see bottom here, we can connect an instance of Modeler to another instance of Modeler. So that's model to model linking. So that's possible as well. We follow this link, not sync approach. So we access the remote data live and there's no data duplication. And that's a very good philosophy that stands us in good stead. Our OSLC server in Modeler provides OSLC 2. OSLC works with the notion of domains. So it has a requirements domain and a spec just for requirements. It has an architecture domain and a specification just for architecture, which is where most of the Modeler elements fall in the architecture domain. The OSLC server is a REST-based API that other tools can use to integrate with Modeler. So any other tool could essentially write a customization that connects to our OSLC API, accesses information from Modeler, and then displays it in whatever tool or web-based tool or desktop tool, or a ThingWorx app, for example. So it serves as a good API to expose our information. Part of this as well as delegated web user interfaces. So as part of this server API, there are web interfaces that allow you to browse through the model data and then select items. So we provide the UI that you can integrate with another application to access and browse and then select items. Conceptually, it looks like this. These show the different tools that we have and the different connections between them, whether they're upstream or downstream. And to kind of simplify this view, essentially what we want is to be able to link all of these three tools, Windchill PLM, RVNS and Modeler, in any direction. So you can create the links in Modeler to the other two tools, or you could create the links in PDM link to the other two tools, or RVNS to the other two tools. So it gives customers lots of options. And And that then, of course, ties into your design process and how you want to work. Which of these tools should be upstream and downstream? In some cases, you may want to start from a Windchill design. Maybe if you're reusing an existing product and changing the design in some way, you kind of start from Windchill and then move into Modeler or into RVNS and start the next phase of redesign there. So how a customer adopts these relationships needs to be carefully thought through, and it relates to the design process, the sequence they want to use, and who is upstream and downstream. So with RVNS, this is what it looks like in Modeler. We have a browser, an OSLC browser, where we can connect to other systems. And you see in this graphic, we connect to doors and RVNS. And then we can either search or browse inside that system to see those resources. And these are requirement resources that we can then use to drag and drop onto our model items, use case in this example. We can navigate those relationships. So when an OSLC link has been created within the model, we can then go and open it, and it will show the preview page that we see here. We use suspecting as well. So when there are changes on the external resource, we can track that in Modeler and show that to the user. So this use case has a link to a requirement, and that requirement has been updated after the link was created. So Modeler denotes that there's been a change, and the user should then go and check whether that link is still valid or not. Following this kind of process. So we establish our links. We can manually set the status. So if we know that the relationship isn't correct or should be reviewed, we can manually set it to suspect. We can then do some analysis. Look visually, run the reports, investigate what's changed in the linked item. So we'd go to RVNS and have a look at that requirement and what's changed. Look at the history. And then we update the link status. We either clear it because the relationship's valid, update the link if it needs to be changed, or delete it if the relationship's no longer needed. We have some reporting capability, and we're planning to build more reporting for end-to-end across the tools. This is really one step of reporting, and it's in Modeler. Show me things that have OSLC links and show me the target of that link. Here's a demo. This is a little old. Modeler 9.1. Ah, look at that. This is our old user interface. I should update this movie, I think, but this shows that adding a connection. So we choose the correct server type, type in the base URL. So this is the OSLC root URL for that server instance. Obviously, when we connect to these systems, we're logging in with an RVNS account. So we are actively logging into that system to be able to access the data, as you would expect. So we can expand the server to view the projects within that system, and then we can view the documents within that system. Expand to view the requirements in that project. If we go and look at that requirement resource, we can see some metadata about it. Here's the body description. And it can be configured on the RVNS side. Usually the OSLC server has configurations which allow you to choose what properties are exposed through OSLC. So if you add some more properties to the requirement type, you can configure OSLC so they come through as well, and we'd see them here in this UI. So to create a link, we just use drag and drop from that browser, and we can drag onto the package browser or a diagram, as we see here. Choose the link type. Click on OK. And then we can view the preview of that link. So we can modify some options. You can look at the metadata. And this is a live view. Whenever we're looking at these OSLC links and any of these properties here, it retrieves them dynamically as we request them. We can look at the suspecting status. Set it to suspect. This is doing it manually. The link has the red diamond to denote. And we'll see that on the model item itself. We can see it in the diagram, but we can also see it here in the package browser. So these capabilities are all the same, regardless of which tool we connect to. The behavior is the same if we connect to Windchill PLM or Modeler or IBM Doors or now Siemens Polarion. So it gives us a very consistent set of functions, a consistent user experience for the modeler user. We can also use OSLC surrogates. So this is when you want to create something a bit more substantial than just a link. So in this case, we're actually going to create a new model item. So we've created something in our database that is in requirement, but it's actually a surrogate. So what that tells us is that the definition of this requirement isn't actually in Modeler. It's in another system in RVNS. It acts as like an OSLC link. Under the covers, it is an OSLC link, but it gives us something that we can actually see in the model and see on a diagram, as we can see here. So it helps you to understand more visually the relationship. It helps you to connect to other items, because we can put these surrogates into diagrams and other model structures. Okay. We're able to see branches and versions in RVNS, and note the new user interface now. So yes, when we look at RVNS data, we denote the branches and the versions using this kind of pattern. The branch is in square brackets. The version is denoted with a dash after the ID. Show that demonstration. So the next important concept that we rely on here is reverse lookups. So we've already said that the OSLC links are stored in one system and they're loosely coupled. So what this means is that, let's say the link is in RVNS. So an RVNS user has created an OSLC link to a model item. Well, the modeler user can't see that link. It's not in their database. So the way they actually see it is using reverse lookup. This gives bidirectional visibility. So basically the Windchill modeler user would have a use case, for example, and then say, okay, I want to know if there are any relationships to my use case. So they can go to RVNS and say, run a query on RVNS and say, do you have any OSLC links that point to this use case? RVNS runs a service, runs the query, and if it finds any requirements that have a link that match the URI, then it will show them and return them to Modeler. So it's really just a query. We call it reverse lookup, but it basically allows a user to see OSLC links in other systems. If they're affecting the model item they're interested in, they want to know if there are any relationships to it. So here's a demonstration of that. First of all, we go into RVNS and create some OSLC links. So we connect to a modeler instance. We browse through the model structure, and here we see a list of use cases. So we create some OSLC links to these use cases. So there's 2 use cases there that we're linking to, and you can see them stored here in RVNS. So the modeler user doesn't have this visibility, but when they're looking at that use case, they can do this run reverse lookup, find external OSLC links, and it will connect to any system that is connected or configured and find any links. So it's connected to RVNS and it's found that requirement that we just created a link from. So we know that there's the bidirectional traceability here. The link is in RVNS pointing to my use case. And if I can see the preview, or if I want to go and see it in more detail, I can jump through to RVNS itself and go and have a look at the details of that relationship. So here's the actual requirement that we linked from in the first place. So reverse lookup is a key concept that gives us that bi-directional traceability between the 3 tools. We have some single sign-on capabilities as well. I won't go into too much detail, but single sign-on is one of the things that we're all been building here. Integration with PDM link. Conceptually just the same as we've seen before, same features and functions. In this case, we run a query. Instead of browsing containers, we run a query, so we see a discrete set of results. We show different versions of parts. So here's the same part with several different versions of it. And this shows that we can create OSLC links to a generic part, but the master, as it's called. And essentially, this is the latest version. If we create the links to these, we create a version-specific link. The link will always point to that version. So if we create a link to C2, it will always point to C2. If we create the link to the latest, as we create new versions, H, J, and so on, the link will point to the latest always. So it's 2 types of modes depending on how you want to manage your relationships. And over time, you might want to change that. It may be that you want to use the latest for an in-work design phase. And then as you finalize the design, you change that link to point to a specific version. So it becomes static and always points to that version. Okay, so here we see it in action. Here's a Windchill system. We run a query and we're querying against the title, the name of a Windchill part. We can use wildcards. Obviously, having a search query helps us manage large data sets in Windchill. And that's something that we'll be looking to do as well with RVNS, is better support for large data sets. Here we see some parts that have been returned and different versions of them. So we can use the drag and drop capabilities we saw before to create OSLC links. So if I select one of these, then I can use drag and drop. And I'm choosing the master part in this case, so it'll always point to the latest. Create a reference link, and there we can see that OSLC link has been created to the Windchill part. And here we create a version-specific link that points to version C of the axle fastener. And when you go and look at the preview page, obviously you'll see the metadata for that specific version. So here are the preview pages that we can see. Open that axle fastener and note that it shows us C1, version C of that item. And as we saw before, you can navigate into Windchill itself, view in the native system, taking us through to Windchill and that information page for that specific part and the specific version of that part. Note that it's not the latest. So Windchill allows us to jump to the latest if we wish to. We can create links in Windchill PDM link. So the same principle, they have a client that can connect to Modeler. So there's an example of using that here. And let me just jump forward. So we create some relationships in Modeler, and then I think I need to scroll back. Yeah, so here we are in Windchill and their OSLC clients. We're looking at a part page, part information page, and the traces tab that's on there. We already have a couple of OSLC links in there. And these are to doors, I think, if I see the table there. So here we connect to Modeler and we choose the type of item we're going to connect to, a package. And then we browse through the Modeler hierarchy. We've improved this user experience now with a selection UI. So it's an easier and faster experience. As we navigate through to the right item, we can then choose the model item. These are packages. So click on OK, and it will create OSLC links to those 3 packages in Windchill. So it's a different user experience on creating links, but it's more familiar to the Windchill user. So that was a design decision by all of the tools, really, that provide an experience that's consistent with what a Windchill user would expect in Windchill and a Modeler user in Modeler. Here we have a preview page. So we can see the previews. This is a pop-up preview. And we have suspecting capabilities as well. That's consistent with Modeler and RVNS. So where it makes sense, we've tried to provide consistent functionality and consistent behavior. The UIs are different. As I mentioned earlier, you can create model-to-model links. This can be used to help with a system-of-system approach. It's quite basic for that, but if you have a decomposed, separated model, you can create relationships between them. And we have the notion of versions in Modeler as well, a live latest version and a version-specific set of data. And we can connect to third-party tools like IBM Doors and Doors Next. OSLC was really pushed forward largely by IBM as a way of connecting different design tools. So they have good support in their tools. This is Doors Next. And we now have capabilities for configuration management across tools. So when we look at Doors data in Modeler, we're actually aware of the configuration that is in Doors, and we get to choose that configuration. So we'll be looking to build similar capabilities into Windchill with the Windchill PDM links configuration spec, where you can choose latest, effectivity, and so on. The same concept, it makes sense really, so that when we look at Windchill data, we could choose a configuration and it would then only show us versions that matched that configuration. So they're the core capabilities, mainly from a modeler perspective, connecting out to the other tools. And as I said at the start, we're building the pieces of the functionality that's allowing us to do end-to-end with reverse lookup, so we can see end-to-end across all of these 3 design tools and third party as well. Interestingly, one of our customers is building reverse lookup from Doors Next actually to Modeler. So they're going to use our API to run a reverse lookup in Modeler. So the same kind of pattern is being adopted by other companies as well. Reviewer is a tool I mentioned earlier, and this has some OSLC reviews. So we can return and review model items with links, without links, with links that are suspect, with surrogates, with suspect surrogates, and surrogates without links to model items. So when you want to review your model overall, you can run these reports and understand all of the relationships and traceability in the model. So these are very useful. Something else that we have that we've found necessary is a tool to update and manage OSLC links. Sometimes, of course, customers rehost servers, so the host name will change, and in that case, the OSLC server name will really change. So we'd need to update all of our links that point to the old server and change them to point to the new server name. So we can do this in a bulk operation, which is fantastic. So this will help maintenance ongoing into the future. Or we can update individual links. So if we want to change a link to point to a different version of a resource, or make it version specific if it's a live link, or vice versa. So it helps us and provides a way to maintain links over time and then convert them to a different resource or to a different version of the same resource. This is the tool that we use. So it reports on all links in a model and then guides you in converting them over to a different server. Okay, so in summary, OSLC is a set of mature standards that make it easy and practical for software tools to share data. Allows you to enable end-to-end processes. They're loosely coupled. So as customers adopt these are one of the these are the principles and concepts they need to understand to use it correctly. The data isn't linked, so there's no duplication, no need for synchronization and checks. We access all remote data live. So this gives us the full breadth of relationships between design tools that help support the digital twin and realize the digital thread. Okay, thanks everybody for your time.